Hi, in this video we're going to be going over the 232 transition code. This code is going to be added to the body code that controls the body for your entire robot. In previous videos we've already covered how to set up the hardware and how the rest of this code works for controlling the robot. And a previous video also covered setting up the Pololu JRK configuration using configuration utility and setting all those settings. So we're going to in this video, we're going to deep dive into the code for controlling the 232. Now, the 232 is how the robot transitions from two-legged mode with the center foot up inside the body to three-legged mode where the center foot comes down, the body rocks back, and he's able to drive around on three legs. And how that's done is through linear actuators that control each of the legs and the center foot. That's three linear actuators altogether with three motor controllers that are controlling each of the feet. And we're using Pololu JRK motor controllers. Let's go ahead and deep dive into the code here. So the first thing you're going to notice is here on the Arduino Uno, the larger pin number goes to the RX jack. That's the receiver jack, and the smaller pin number goes to the transmitter jack, the TX jack. On some Arduino codes, this is reversed, so you have to look up for whichever one you're using, Mega, Uno, whichever one you're going to use. So be aware of that. First thing we're going to do is we're going to set up the software serial ports. So we're going to name one the JRK left, that controls the left actuator, the right controls the right actuator, and the foot, which controls the foot actuator. And these are the pins that are going to connect to each of the systems, as described in the hardware video. So next we're going to assign the device numbers to the JRKs. So as you did in the setup tutorial for the device numbers for each of those things, they all, as you know, they all default to 11, which in hexadecimal, that's 0x0b. And then you want to have each one assigned a unique one so you can chain them and you can talk to them separately. So these are you assign the hex values for each of the device numbers. For example, A for 10, B for 11, and C for 12. Now the next part is where you have to do some calibration for your particular robot. So we're going to be setting the minimum and maximum position for the legs, and you can see how that can be calibrated in your JRK configuration utility. You check the automatically set target. And then you can slide in the bar, you can slide up and down and watch your actuator go up and down. And then you can set the true min and maxes on there. Once you've set it up on your robot, you're going to want to calibrate it again for what the min and max that the robot can actually do inside the frame. So for mine, I was able to set it to these numbers. So leg position for two-legged mode is 1430. And for the three-legged mode, it's 1560. And I took a note on mine as which one was the actual max on the linear actuator. Then we can calculate and hard code this, the middle position of the leg. So middle position is just leg position 2, leg position 3 divided by 2, and we get 1985. And then we do the same thing for the center foot. So you're going to do center position 2, center position three-legged, and calculate the middle. This one's a little bit different because this is kind of like, you know, the position 2 plus position 3 divided by 2 is really just your starting position. This is you're going to want to calibrate back and forth to see where it's actually safe to set this for his tilt. Otherwise, he'll tip over. So that's going to take you some going back and forth, and you're going to be catching the robot often in order to set this up. Next, we're going to initialize the legs, and we're going to call this function that we write here in the at the end of the setup function call for your Arduino body code. So in here, we're telling the serial connector that we set up earlier to begin with the 9600 baud rate. And then we put a little console print line so we can see that we've done this in the console. As you run it, you'll see this as outputs. Do the same thing for the right foot, or the right leg, and the center foot. And now we move on to the interesting functions. So now this is how we're going to actually do the actual movement. These functions that we're creating here are going to be called in your body controller in the loop that are called based on your Xbox controller commands. So in order to move the legs, you want to move both the left and the right at the same time. Otherwise, he's obviously going to tip over. So we're just going to pass in an unsigned integer, 16-bit size, called target. We do some little console output for debugging, see that we actually got the commands from the Xbox controller. And then we write those commands through the serial interface to the Pololu JRK motor controllers. So the way they set up their protocol is, and this is from their user guide, you first transmit 0xAA as the first command byte, followed by the device number, data byte, followed by the command byte with the MSB cleared, and then you add in any other necessary data bytes for that command. So what we're going to do here is we're going to tell that leg to move. And the way we're going to do that is tell the motor controller, which tells the linear actuator, to move a certain distance. So we first pass the 0xAA value, then the device number that we set up previously, a starter byte of 0x40 plus the target, and you add the 0x1f byte. Now, this part you don't even need to understand. It's just something that's in their protocol from the user guide. All you need to understand is the order and this recipe, and the fact that you're passing in the target number that you passed in there. From there, what it's doing is it's splitting the bytes into multiple commands because the command you're trying to pass it is too big for what that serial port can take as a byte, and so you're just splitting it up into two different transmissions. But you don't really need to understand that. Just follow this recipe and you'll be fine. And the next line you do the target bit shift 5, and then the end bit of 0x7f. So from there you do the exact same thing for the right leg, following the same recipe. And then at the end you just output some debugging info to the console. So now we're going to add some commands for doing some debugging in case things don't go according to plan while you're testing it on the body. So we've added some functions here that just get you the positions of where things actually are. So in the show current leg and foot positions function, we just use the feedback command of 0A5. And there's also a scaled feedback command for A7. But the Pololu user guide has more info on the difference between the two, but for now we're just going to be using A5 for all of our position, so we get the exact feedback command. So basically what we do is we say get the foot position, the left leg position, the right leg position, and just output them to the console for debugging purposes. Now the interesting part is the functions that actually get the foot positions and leg positions. Now that we have to do some interesting bit operations here. That's different than the other recipe that we did for telling it where to go. Basically what we got to do is we got to create a character array. We're going to call it response. It's a 2-character array. We're going to start listening to the motor control. In this case, we're doing the center foot. We say start to listen. Then you say set the command, which is the typical AA. Here we go. And then the device name, and then the command. Now, the command is the feedback command that's passed in up above here. So see up in the get foot position is where we set that. And that just tells you to use the feedback commands. And then the tricky part is down here is where you have to wait. So you send the command and then you got to wait for that response, and that takes a bit. So the way we do that is, well, with a while loop. So we say wait for the motor controller to become available, and that number has to be, the way that's outputted is, it has to be less than 2. You sit there and wait for that, and then you read the bytes that comes from that response. And we're grabbing the correct bytes from the response array. And then we have to then put the response back together again using the word method. And with the last one first and the first one last. That's just their crazy protocol. And from that, you'll find out what the exact position would be, and that's going to be a number like 1432, and you can compare that to what your min max is and what the middle positions are. And you do the exact same thing for the leg position and the right position, and that's how you do some debugging. Okay, so now we're down in the loop method of the body code, where we're going to actually call the functions that we created for the motor controller from the Xbox controller commands. What we're going to be doing is we're going to have, the way you're going to transition from two-legged to three-legged using the Xbox controllers, we're going to hold down L1 and then push up and down on the D-pad to do the transition. And the reason is you want to have 2 button commands. That way you don't accidentally trigger it while you're trying to do other things. You don't want them to suddenly start transitioning from two-legged second to the three-legged and back forth while you're driving around doing other things. So it's kind of a safety feature there. So what we're going to do is we're going to say if your Xbox receiver is got an up command, then and you also have the L1 pressed at the same time, then you output to the console some info for debugging purposes, and then you're also going to move the legs, both of them at the same time, to position 2, and then you're going to wait for those legs to get to the middle position, and then you're going to start moving the center foot into position 2, and then you're going to output some debug information. And so the reason why you want to wait is just for safety purposes. You want to make sure that the legs are in fact moving before you start moving the center foot. That's to keep him from flipping over. And you'll need to calibrate this back and forth in your actual system in order to get that timing and that little dance correct. And so now we do the exact same thing for three-legged mode. You wait for the button click event on the Xbox controller for down, along with the L1. You begin the down movement. You tell the foot to start moving, and then you wait for that foot to reach the middle position. This is to help him keep from tipping over. And then you start moving the legs into position 3. And that's it. And as you see, the code here is very clean. It's very simple. There's a separation of concerns here. So his concern is just tell the motor controller code to go do it. It's not really concerned about how it does it. And so this way you keep the code very clean, and you can more easily read it and debug it and support it later. And the code that actually does the work of talking to the motor controller and linear actuator is obfuscated from this part of the code. It's just hidden behind a black box. It just says go do it. So it just makes it easier to read and understand. So now we add a little bit of code here that helps you do some calibration and debugging when you first set up the robot. You probably won't be using this in general use, but this helps you find, say, the min and max of the different values for your center foot and leg positions. It helps you dial in to the proper middle position to keep him from tipping over, that sort of thing. And you can dial this in here for just either the center foot, or each of the legs, just by commenting out the code here. Here you just comment out, say, the legs. That way you can just do the foot and vice versa. And the way you do that is we're just going to say when you're holding down the L1 trigger and you hit the right or left buttons on the D-pad, that's going to move those positions just a little bit. And so the way that code works is you get the center foot position as just an int, calling one of those debug methods that we created earlier. Then you move that foot to that position plus just a little bit, and 100 is just a tiny movement of the linear actuator. And you do the same thing for left button as well. And that's it. So that's really all there is to it. I hope you've enjoyed this. Future video, I'm going to show how to actually run this live in the robot so you can see the debugging outputs as it goes along. Thanks a lot. Bye-bye.